The year 2026 has barely begun, yet Elon Musk has already set the tone by declaring that 2026 will be a banger. That statement was quickly followed by a surprise that lived up to the hype: the appearance of a refreshed Tesla Semi, commonly referred to as the semi-truck next gen. This marks the first time in nearly 8 years that the Tesla Semi has been seen in a substantially updated form at Giga Nevada. Until now, changes had only been teased through partial images shown at Tesla's November shareholder event. Seeing the redesigned truck in the real world confirms that Tesla has been quietly making meaningful progress behind the scenes. For many observers, this moment feels long overdue. The Tesla Semi has been discussed, delayed, tested, and refined for years, and expectations have steadily grown. The newly spotted version already reveals at least 11 major updates and improvements, signaling that Tesla is finally preparing to move the Semi into its next phase. As a reminder, the Tesla Semi is built at Giga Nevada, with production expected to expand into a nearby facility as volumes increase. Giga Nevada has long been a cornerstone of Tesla's manufacturing ecosystem. It produces drive units, battery packs, and energy products, and has played a vital role in scaling production for vehicles like the Model 3 and Model Y. Even today, it remains Tesla's primary hub for battery and powertrain manufacturing in the United States. Toward the end of 2026, the factory reached an impressive milestone by producing its 6 millionth drive unit, a moment Elon Musk publicly acknowledged by congratulating the Giga Nevada team. The renewed attention on the Tesla Semi began when a longtime semi enthusiast, known for documenting construction progress at Tesla's Nevada facilities, inadvertently captured drone footage of a Class 8 truck with a completely new exterior. Once those images surfaced online, automotive analyst Sawyer Merritt quickly compiled a list of at least 11 confirmed updates. These included a Model Y-style light bar, improved efficiency, increased payload capacity, energy consumption of 1.7 kilowatt-hours per mile, a 15% efficiency improvement over the previous version, autonomous-ready design, a 500-mile range, peak charging of 1.2 megawatts, 800 kilowatts of drive power, revised side window placement, added anti-slip traction steps, and numerous internal upgrades. Among these changes, the most visually striking is the new front light bar. It closely resembles the design used on the Model Y, though scaled up to suit the Semi's larger proportions. Compared to the previous headlight design, this new lighting setup gives the truck a cleaner, more modern appearance. While the older headlights were distinctive and powerful, many will likely find the new design more refined and consistent with Tesla's current design language. Efficiency improvements were another key point raised by Merritt, though the term itself covers a wide range of potential enhancements. These likely include aerodynamic refinements, drivetrain optimization, improved energy management, and software updates. Alongside this, Tesla has reportedly increased the Semi's payload capacity, an especially critical metric in commercial trucking. There are two main ways Tesla could have achieved this payload increase. One approach would be reducing the tractor's curb weight by using lighter, high-strength materials such as aluminum alloys, advanced steels, or composites. If Tesla revised the frame, cab, or structural components, even small weight reductions could translate directly into higher cargo capacity. While this possibility has not been confirmed, it remains a plausible explanation. The second and more clearly supported explanation involves battery technology. Tesla has already confirmed that the Semi will transition to a new battery architecture, allowing the pack to weigh less while delivering the same usable range. This change was previously hinted at by Tesla executive Dan Priestley, who revealed that the Semi would move to a high-voltage battery system using 4680 cells. Earlier Semi prototypes relied on lithium iron phosphate batteries, chosen for their cost efficiency and safety. However, LFP cells have relatively low energy density. To achieve a 500-mile range, Tesla needed to install a very large battery pack, around 900 kilowatt-hours, containing a high number of individual cells. This added significant weight and reduced payload capacity. By switching to 4,680 cells with nearly double the energy density, around 300 watt-hours per kilogram, compared to roughly 175 watt-hours per kilogram for LFP, Tesla can achieve the same range with fewer cells and less mass. This not only reduces vehicle weight, but also lowers manufacturing complexity and improves overall efficiency, making the Semi more competitive in real-world freight operations. Another major improvement is the Semi's reported energy consumption of just 1.7 kilowatt-hours per mile. This represents approximately a 15% efficiency gain over the previous generation. In long-haul trucking, even minor efficiency gains can result in substantial cost savings over hundreds of thousands of miles. Lower energy consumption directly reduces electricity costs and allows fleets to operate more profitably. At this efficiency level, the Tesla Semi approaches territory once reserved for much smaller electric vehicles. Over the lifetime of a truck, this translates into reduced battery requirements per trip or extended range using the same pack. Both outcomes reduce upfront costs and further improve payload capacity, creating a compounding advantage. Despite earlier speculation about longer ranges, Tesla has confirmed that the Semi will retain a 500-mile range. Rather than extending range, Tesla appears focused on optimizing weight, cost, and efficiency. By shrinking the battery pack while maintaining range, the company can deliver a lighter, more affordable truck without compromising performance. So what's new in this version, and how will the Tesla Semi convince diesel truck drivers to make the switch? Before we begin, please help us reach 20,000 subscribers. It will be a huge motivation for us to continue bringing you great episodes about Tesla EVs and the latest news. This is Tesla's brand new factory expansion at Giga Nevada, built specifically for producing the electric Semi truck. Its massive scale easily qualifies it as a semi-gigafactory. Previously, Tesla built the Semi almost entirely by hand in limited quantities, but with the new facility, production will shift to a fully automated assembly line. It's impressive that Tesla completed such a huge expansion in a relatively short time, and recent updates show the plant fully equipped and gearing up for volume output. With the new factory and automated production lines in place, Tesla confirms an annual capacity of 50,000 Semi trucks is achievable, giving the company the ability to compete with the output of traditional heavy-duty truck manufacturers. In the trucking sector, Tesla's biggest U.S. competitor remains brands like Peterbilt, which produce tens of thousands of heavy-duty trucks annually. Elon Musk is confident this Nevada facility is a solid foundation for making Tesla a serious player in the heavy-duty truck market. More importantly, the Tesla Semis rolling off this production line will differ significantly from early units. Musk has been open that the Semis already on the road, even those delivered to customers, are essentially advanced prototypes used to gather real-world data. For that reason, the core design had remained largely unchanged since the 2017 debut. Now, a comprehensive refresh has arrived, not just for a more modern look, but to support the ambitious goal of full autonomy in a Class 8 truck. The company revealed the refreshed design through images at the 2025 shareholder meeting. The headlights have been redesigned to align with the latest Model Y, Cybercab, and Cybertruck, featuring a continuous light bar that stretches across the front of the cabin for a sleek, aerodynamic appearance. Tesla has also added a new front bumper and a smoother, more rounded roofline. The most noticeable change in the upgraded version is the shortened windshield, set further back from the cabin's leading edge. While some initially viewed this as a cost-saving measure, it actually improves both aerodynamics and safety. The original Semi featured an expansive windshield for panoramic visibility, but much of the rear glass was redundant while creating drag. The new design maintains full width but reduces height, allowing smoother airflow over the cab, lowering the drag coefficient, and reducing turbulence around the A-pillars. It also limits direct sunlight into the cabin, easing the load on climate control and preserving battery efficiency. Currently, early Semi units use LFP batteries, but the production version is expected to transition toward greater incorporation of Tesla's 4680 cells. The 4680 remains the company's most advanced cell format, offering higher energy density, around 300 watt-hours per kilogram, along with lower production costs through innovative tabless and structural design. This shift will enable greater range, potentially exceeding 500 miles with full payload, while reducing overall vehicle weight and operating costs. These enhancements are critical for FSD integration. The smoother contours and repositioned glass improve sensor placement and field of view for cameras and radars, eliminating blind spots that plagued earlier prototypes. Musk has stated that production Semis will ship FSD-ready, setting the stage for supervised and eventually unsupervised autonomous operation in commercial fleets. Inside the Nevada factory, automated lines are now active for low-volume builds, with multiple Semis visible in various assembly stages. The facility's completion marks a milestone, positioning Tesla for the promised 2026 ramp-up. As of December 2025, Tesla continues limited deliveries to gather final data. Most notably, DHL Supply Chain recently took delivery of its first Tesla Semi in California, deploying it on regional routes and planning significant fleet expansion in 2026 as volume production begins. This follows ongoing operations by PepsiCo and other early partners, with roughly 70 to 100 units delivered to date. Supporting the Semi's rollout, Tesla is aggressively building charging infrastructure. Megachargers capable of over 1 megawatt delivery are being installed at customer depots, with recent expansions at PepsiCo sites in Denver and elsewhere. The company has also committed to a public semi-charging network, planning 46 dedicated stations by 2027 to enable cross-country operations without reliance on private facilities. Meanwhile, Tesla's broader supercharger network continues explosive growth in 2025, adding thousands of stalls and opening access to over 15 non-Tesla brands through NACS adoption. This vast, reliable infrastructure underscores Tesla's charging expertise and indirectly supports the electric trucking transition by normalizing fast charging nationwide. With the redesigned Gen 2 Semi, a completed high-volume factory, expanding Megacharger network, and proven real-world performance, Tesla is finally poised to disrupt heavy-duty trucking. Lower total ownership costs, zero emissions, superior efficiency, and eventual autonomy offer compelling advantages over diesel. As production scales dramatically in 2026, more major fleets are expected to commit, accelerating the shift to sustainable long-haul transport. We hope to bring the best information to you. Please give a thumbs up if you like this, subscribing, and hit the bell icon so you will not miss out on any awesome videos. We value your feedback. Thanks for watching. Until then, stay safe and have fun.